Hey guys, so today we'll be studying the maximum subarray sum with one deletion. Now the question says that we need to return the maximum sum for a non-empty subarray with at most one deletion. Now what you want to do over here is that let's say that you're given an array. Now from that given array you can select any subarray. Subarray is what? Contiguous elements. Now from that what you can do is that you can optionally delete one element from it such that the element, the overall, you get some good max values, right? So how will we go about solving this question? Let's say that we are considering this part. Okay. Now in this part, you can clearly see that what can happen over here is that there are a lot of different subarray which are possible over here. The subarray can start from index 0 and maybe it can end at 1 or it can end at 2. And there are more subarray which are eventually possible starting from index 1 till this point. So a lot of different possibilities. Now, how will we go about solving this given question? How will we go about solving this given question? Now, let's say that I will give you the first end. Let's say that the question says that we need to do one deletion. For our given example, let's say that we select the whole array. When we select the whole array, what we can eventually say is that, oh, my sum will become what? Think about it. This part will become minus 2 plus 1 minus 1, and the minus 1 plus 3 will become 2. So no, I know that some element in my life is hindering my progress. Okay, so but God has given me one option. God has given me option that you can remove that one particular element. So let's remove that. And when we remove it, our overall sum becomes 4, and this is our best answer. Now, some students actually what they do is that they do not read the question properly, and for this given example, what they do is that let's say that we know that selecting the entire array will become the whole array will become what? Minus 4, and that's too much negativity. So what they do is that they say that, oh, I'll select minus 1. Okay, and after selecting minus 1, they say that, oh, this is causing me some negativity. I will remove this minus 1, and what they do is they return at the end of the day an empty subarray. But the question explicitly says that the subarray needs to be non-empty. So even after deleting one element, the subarray should be non-empty, right? So take care of the scenario. Do not miss this edge case and ensure that you're following the right thing. So now we have discussed the this thing, and now let's see that how we can go about solving this question. Now the question says that one deletion. Let's say that there were no deletion. What will be this question becoming then? Maximum subarray sum. Have we done question like this before? Yes, we have done questions like Kadane algorithm. This is a very classic algorithm, and I think so every student must have done this in their life. But if you have not, I would first recommend you to watch that Kadane algorithm video. There are a lot of YouTubers who have made a very good, excellent content on that. So I will highly recommend you to first revise that concept and then come over here. So let's say that now we are aware that what is Kadane algorithm. Let's say I'll just give a quick intro. So we started, let's say there is an array which starts at index 0 and ends at n minus 1. What can eventually happen over here is that we know that this array, when we run a Kadane algorithm, at the end of this algorithm, we'll get what it will indicate. It will give me the maximum subarray, right? It will give me the maximum subarray sum. So what if we apply the same concept over here, but instead of n minus 1, we change the index. Instead of n minus 1, we change the index. Let's understand what. Let's say that there is an ith element. Okay, and its value is ai something. Now, there will be certain elements which will exist on the left hand side, and there will be certain elements which will exist on the right hand side. Now, what can happen as part of this? So, we can say that this index will start from 0 and it will go till I minus 1, and this index will start from I plus 1 and it will go till n minus 1. Right? Now, what we can do about this thing is that we know there are left hand part and there are right part. Now, we need to find out the maximum subarray sum with one deletion. So let's say for a given example, we decide that, okay, we will not exclude of AI. Okay, we will not include this thing. We will exclude it. So what can happen now? What if we run the Kadane algorithm from 0 to I minus 1? And what if I run my Kadane algorithm for the RHS side, but I do some fancy operation? I do not run from I plus 1 to n minus 1. Because that will give me the maximum subarray at this point. What I will eventually do is that I will run from the reverse side. I will start from n minus 1 and then I will go to I plus 1. And at this given point, I will get the maximum subarray for the RHS side. Okay, for the RHS side. And when we exclude this given element, when we exclude this given element, let's say that the LHS sum is LHS and the RHS sum is RHS, the answer will be nothing but LHS plus RHS. That's all. Okay. Now you might have one more confusion. How about calculating for other elements? For other elements is also very easy, because now we need to eventually do is that the I will move, right, and this will become what, I a of I plus 1, and this will become what, this will become I plus 2, and this is n minus 1, I know, something like this. Now what can eventually happen over here is that for this given element, we need to again rerun our Kadane algorithm. We were running from 0 to I minus 1. Again we need to run for I this element I. So we are going to do what we call a pro move. So what we are going to do is that instead of calculating again, we are going to construct an array of LHS, which indicates the maximum subarray sum, which starts at index 0 and end at n minus 1, and each index will indicate the maximum subarray at that particular index. So again we do not need to recalculate it. We are going to use the LHS, and we are going to construct the RHS as well to construct our given array, and we are going to run the LHS from 0 to n minus 1 and RHS from n minus 1 to 0. So that's all, guys. Now I think so you might have one final question, that hey, what if we are excluding this a of a, what if we include it, this is a very classic common question, and you are right to ask this question. If you have thought about it, you have a very good IQ. So now what I'll say is that now what can eventually happen is that देखो, if you're planning to include it, won't this algorithm just become like calculating the maximum subarray? Won't that be the thing? So now what you need to eventually do is that in this entire thing, 0 to n minus 1, if we just say that if there are no deletion, if we just calculate the maximum subarray, which will be present over here, we won't be able to find our answer of the overall max, right? So that's become like classic Kadane algorithm. There is nothing to think over here. है ना? So that's why we are only going to take the option to exclude this, not include this. But if we were to include this, then it would become like you are just connecting the left part and the right part, and there is no point. Okay, so that is a classic Kadane algorithm. I mean, you can do, but eventually you will get the same answer. So nothing fancy is gonna happen. So that's about it, guys. But I'm going to give you another approach, because interviewer will expect you that, okay, you might mess up during your interview. I'll just be honest. So it's always good to have more than one or two approaches while you're preparing. So I want to give you one more hint over here. How many states are possible? There are two states. The states are what? The include state and the exclude state. Now in the include state, we take that element, and exclude state, we exclude that element. As simple as that. I mean, what am I even saying about this? So, but the thing is that excluding is not very easy thing, because we have to ensure that we are excluding only one time, right? Now I'm saying something. So there are two states possible. That's why we are going to use something called, I will take a pause over here. You can think for yourself. Yep, dynamic programming. Let's understand that how will we make it work for the dynamic programming. Now I understand there are two states associated. Let the first row indicate no deletion wala, okay? And the next row will indicate deletion. Okay? Let this be dp of I comma 0, and let this be dp of I comma 1. As simple as that. So I'll start talking about the index 0. So let's say that there are no deletion. No deletion मतलब क्या होगा? पहला एलिमेंट है a of, and let's suppose that कि हमारा array कुछ a of 0 है, a of 1 है, a of, it will go till a of n. Now what you will think, what is the value which you will get over here? A of 0, है ना? Because you are doing no deletion. And let's say that you were deleting a of 0, what value will you get over here? 0. Okay, this is very easy. This is very easy. Now comes very difficult part. How will you solve for the next given index? How will you solve for the next given index? So note, if there is no deletion, मतलब तुम क्या run कर रहे हो? Kadane algorithm ही run कर रहे हो. So you have two options. Either you can select a of 1. Kadane algorithm तो यही बोलता है ना. The maximum at this point will be either a of 1 or a of 1 plus the dp of 0, dp of I comma 0. As simple as that. यहां की बात कर रहा हूं. फिर से सोचना, ये तो क्लासिक Kadane एल्गोरिथम हो गया ना, क्योंकि हम नो डिलीशन कर रहे हैं, तो इसका वैल्यू तो हम तुरंत रियलाइज कर सकते हैं, और बाकी वैल्यूज को भी all these values after this indexes can be easily be filled using this approach. Now I'm going to talk about the next interesting thing. The next interesting thing is that how will you fill for this row, the next given row, for the deleting elements. Now understand this thing, okay? Whenever I say dynamic programming, it's always like you start with some given intuition. Now over here, the thing over here is that what the state indicates, you have to understand, you have to tell yourself, this state indicates one deletion. This state given one deletion. And we have already solved this. We are focusing on this one. So now just understand, if I were to have no deletion, अगर मैं पहला ही state dp of I comma 0 पे क्या assume किया था मैंने, there were no deletion. So if I were to copy this over here, ऐसे का वैसे ही, then I am just doing a blunder. Can you tell me why? अगर मेरा क्वेश्चन क्या है ना कि अगर ये क्या लिखा है 0, अगर मैं चुपचाप यही 0 इधर कॉपी कर दूंगा तो वाई आई एम डूइंग ब्लंडर, I-1 लिख दो इसको यार थोड़ा. तो कैन यू गाइस टेल मी व्हाई आई एम डूइंग अ ब्लंडर? कैन यू टेल मी? बिकॉज वी आर एक्सक्लूडिंग द गिवन a of 1 ट्वाइस. ठीक है, ये a of 1 होगा बेसिकली इसका एलिमेंट का वैल्यू. तो तुम क्या कर रहे हो, इधर भी एक्सक्लूड कर रहे हो, इधर भी एक्सक्लूड कर रहे हो. तो वो तो नहीं कर सकते. यू कैन नॉट एक्सक्लूड वन गिवन एलिमेंट ट्वाइस. So what you have to do? What you have to do is that you have to include that given element. You have to include a of 1. So यहाँ पे जो आंसर होगा ना वो क्या होगा? Either you can get the answer as max of that. So this will be dp of I minus 1 comma 1. जैसा पहले वाला स्टेट था वही स्टेट इधर कॉपी कर दो. Plus you have to include it. Plus you have to include the current element. Because if you're not including it, तुम दो बार इसको एक्सक्लूड कर रहे हो जो गलत हो जाएगा. यू डू नॉट हैव टू डू दैट. और अंडरस्टैंड दिस फैक्ट. व्हाट डज दिस स्टेट रिप्रेजेंट? व्हाट डज दिस स्टेट रिप्रेजेंट? दिस मीन्स कि हम उसको यहां पे क्या कर रहे थे कि ये सारे स्टेट्स को रिप्रेजेंट कर रहा है I-1 तक, जहां तक हमने इंक्लूड करके रखा था. ठीक है, तो हम a of 1 को कब एक्सक्लूड कर सकते हैं? जब हमने पिछले बार सारे स्टेट्स को इंक्लूड किया हो, है ना. तो इसका आंसर क्या हो जाएगा? dp ऑफ I-1 comma 0. That's it. That's it. ये आपका कोड बन गया. लॉजिक काफी सिंपल है. लॉजिक काफी सिंपल है. एंड इसके ऊपर ना आप चैट जीपीटी से पूछ सकते हो कि इसको स्पेस ऑप्टिमाइज कैसे कर सकते हैं, वो कैसे कर सकते हैं. बट दिस इज द कोर लॉजिक ऑफ दिस केपी. आई एम गोइंग टू शो यू द कोड. कुछ नहीं करना था. ठीक है, जैसे मैंने इंडिकेट किया एरे ऑफ ए आई, जैसे कि यहाँ पे बोले ये तो क्लासिक कडान एल्गोरिथम है. I-1 कॉमा 0 प्लस एरे ऑफ आई, ये क्लासिक कडान एल्गोरिथम रन किया मैंने. और मैंने दूसरी चीज स्टेटमेंट में क्या बोला, डीपी ऑफ आई कॉमा 1 इंडिकेट करता है कि वन एक्सक्लूशन. तो या तो तुम पहले वाला स्टेट को वैसे का वैसा कॉपी कर दो. ठीक है, I-1 का स्टेट वैसे का वैसा कॉपी कर दिया मैंने. प्लस मैंने करंट एलिमेंट को इंक्लूड किया, क्योंकि हम लोग एक ही एलिमेंट को दो बार क्यों एक्सक्लूड. देखो डीपी ऑफ I-1 क्या इंडिकेट कर, हमने ऑलरेडी एक बार एक्सक्लूड कर दिया. तुम अगर एरे ऑफ ए आई नहीं लिखोगे तो मतलब क्या कर रहे हो तुम? You are excluding that twice, dude. So get that thing right. And the thing over here is that we have to, this is possible. Otherwise, you can exclude the array of I after you include all the previous element. ये वाला क्या state represent कर रहा है? All my no deletion वाला state. ठीक है? So तुम्हें अगर चाहिए ना, I'll give you one more thing. You can solve कौन से क्वेश्चन थे? हाँ, buy and sell stocks वाले questions, and then you can easily get this grip of the concept. बड़ा ही इंटरेस्टिंग कॉन्सेप्ट है, बहुत ही इंटरेस्टिंग कॉन्सेप्ट है. एंड yeah, that's it guys. I mean that's all from my side. It took me a lot of take to just to get the delivery right. I hope you enjoyed the video. It took a lot of effort for me, yeah, to get one take right. So apparently it's a good video, and I think so इससे काफ़ी ज़्यादा हमारा रिविजन हो जा रहा है. इससे हमारा डायनेमिक प्रोग्रामिंग रिविजन हो रहा है, इससे हमारा कडान एल्गोरिथम रिविजन हो रहा है. एंड एक बात बोलूँ तुम्हें, ये जो क्वेश्चन है ना, लोग बोलते हैं ना कि काफ़ी लीड कोड क्वेश्चन है. ऐसा नहीं होता. दिस इज जस्ट अ रेपिटेशन. देयर इज नथिंग लाइक अ न्यू लीड कोड क्वेश्चन. कोई तुमसे आके कोई नया एल्गोरिथम नहीं पूछ देगा. लीड कोड क्वेश्चंस आर जस्ट लॉजिकल बेसिस. ठीक है, अगर मैं तुम्हें बाय एंड सेल स्टॉक भी बताऊं तो वो भी सिमिलर कॉन्सेप्ट पे ही वर्क कर रहा है. उसमें भी आपके पास क्या, अगर उसके दूसरे वेरिएशंस आप देखोगे तो दूसरे वेरिएशन में भी यही है कि आप एक टाइम पे शायद से एक ही स्टॉक होल्ड कर सकते हो. ठीक है, और ये जो डीपी है ना तुम्हारा, वही चीज कर सकता है. मतलब अगर तुम स्टॉक से रिप्लेस कर दोगे ना इसको, मतलब यहाँ पे तुम सारे स्टॉक्स होल्ड कर रहे हो, यहाँ पे सिर्फ एक स्टॉक होल्ड कर रहे हो, ऐसा बन जाता है तुम्हारा क्वेश्चन. तो इस पे आई विल हाईली रिकमेंड यू दैट यू एक्सपेरिमेंट विद द क्वेश्चन इटसेल्फ. ताकि तुम्हारा दिमाग खुल जाए। तो अगर ऐसे 3-4 टाइप की वेरिएशंस करोगे तो यू विल बिकम अ प्रो। So that's it guys. I think so I'll from my side. If you have any questions and anything, just drop it on the comment section. I hope you enjoyed the video, Hannah. So hasta la vista. Bye bye.